All right. Hello and welcome everybody to the July 2017 monthly 3D printing and 3D design webinar. My name is Nick Klosky and I am the co-founder of Honeypoint 3D. And I want to say thank you for everybody that showed up, and for the people who watch this on replay, I want to say welcome to you. We have a couple of questions this month from people who sent me some questions on how to do things, so I will certainly get to those. I also promised in my email that went out that I will deal a little bit with this over here a little bit, that I will deal with 3D printing in multi-materials, because I just got a new printer that can do that, and I've been waiting a long time for the ability to do that, and I wanted to kind of share some thoughts on that. And as always, please use the online question little chat component there to ask me any questions that you have about 3D printing, 3D design, design for manufacturing, really anything like that. Honeypoint 3D does design services, so we help create 3D models. Now, we do that in two different ways. We do that via professional services, so we help people create models with our own engineers, sometimes on napkin drawings, or sometimes pieces of paper, or sometimes fully dimensioned drawings. We can turn that into CAD, and we do that actually for clients across the country. And the other side of our business is helping people do the 3D modeling themselves. So a lot of times we get people coming in that ask us how to create models, and then we create the models, and then we sell them an online class where they can now take those models and modify them themselves later on. You know, our engineers, as well as myself a little bit, but mostly our engineers are really good at doing design for manufacturing and all of those other considerations. And so that's kind of a little bit about Honeypoint 3D. I want to, again, make sure that if anybody wants to ask any questions, I will be very, very happy to answer them. I want to get to the question first, actually, from one of our users. Let me screen share here, like that. And I think you can kind of see me both for right now, but let me turn off all of these and I'll just so we had a question come in. Let me kind of bring this in here and then go like this. We had a question come in from Roman about how to do a couple of different things inside of Fusion. Let me kind of move this over here like that. How to create these sorts of cuts. This is actually for a lightsaber. How to create these cuts inside of Fusion, or these features, and then we'll get to the second question in a moment here. Bring this over here and then go into Fusion like this. Let me just kind of arrange some things here. Okay, great. So let's create a lightsaber here. I'm going to go into Modify. This is in Fusion 360, and if anybody has any questions about that, I will be happy to tell them about Fusion. But I'm going to go in and create just a cylinder here, which is, vaguely lightsaber shaped. All right. We have a handle for the lightsaber. You can kind of see this right here. And I base that right on the origin. You can see the origin down at the bottom here. Now, the first question, if I kind of bring this back in, is how to do these cuts on the handle. What I can actually even do to make this super easy is I can actually attach a canvas in here so we can actually see this handle as we're modeling. I guess I'll just kind of put it here. And actually what I'm going to do is I'm going to put it on this face just because it makes more sense to me. And this is just kind of a template, right? So I'm just going to move this down here. So that is what I want to create. Now, if we see these cuts here, these are kind of a simple cut. And so what I'm going to do is I have my origin turned on. You can see that I have kind of these planes already set up. These are just the planes from the origin right here. I'm going to say sketch and say create a sketch, and I'm going to select the plane that bisects the cylinder that I created. So that plane right there. It kind of orients my view that way. I don't entirely like that. I'm going to go like this to kind of make it the same, and go in and look at it. And it did it again. All right. Now I'm going to create a sketch with just something like a rectangle. So I'm going to say 2-point rectangle. I'm going to kind of hover my mouse over the origin so it locks. You can kind of see a blue line coming out of it. And I'll kind of go up here and I'll just click and draw a rectangle out. Now I can dimension this rectangle if I want. If I hit the D key, D for dimension, and I go out, and it says that this is, I'm going to say just 4 millimeters. It'll make it a little bit more skinny, and I don't really care about the height. That's fine for what we're doing right now. And I'm just going to say stop sketch, like that. So now you see we have a sketch kind of going right through the middle of this. I'm going to click on the sketch and then right click and say extrude. I'm going to have this come out, and I'm actually going to say the direction is symmetric, like that. It automatically assumed that I was cutting through, which I do want to do. And I say cut. And now we have a kind of cut going through there. And now we want to essentially copy this all the way down. So we want to create a pattern for it. So pattern, a rectangular pattern. And what we would want to do is, so here's some kind of tips in Fusion that it took me a long time to kind of learn. So right now we have pattern, normally it's kind of defaults to pattern faces. In this case we have 1, 2, 3 faces that we could pattern, but that's not entirely what we want. It'll totally work, but if you have the ability to change this to features, you should always do that, because this is much more lightweight on Fusion. Faces is great for just 3 faces, that's fine, but if you had 3 faces then getting mirrored into like 100 different patterns, it can kind of start to hurt performance. So if you can go to features, that's what you would want to do. In this case, and let me actually make sure here that I'm doing this the right way. I'm going to make this a little bit smaller just to make sure that for the replay folks can actually see this, and they weren't able to see this. Let me just make it a little bit smaller here. Bear with me just for one moment. Okay, there, perfect for the replay. Now, if we say up here, pattern features, that's what we want. So features, you notice I can't click anything around. Features allows me to click things down here on the timeline. So I want to actually pattern this extrusion. So if I click on that, then it works. So I have one object selected. Direction, I'm going to click on this direction right here, which allows me to drag new ones down. And see it says 3 and 3. I don't entirely know which one is which. If you see me drag this, you see that this distance is coming out. There's no distance here, which really means that I could pattern up above, but I don't want them up above. So I'm going to select this quantity to just 1, which is right here. And then this guy, I can kind of drag this out. I can say, you know, I want 3 or 4 or 5, 6, something like that. I can do all sorts of things. I can say, you know, I can go to extent, or I can say, you know, I essentially want them 9 millimeters apart, or, you know, 5 millimeters. So I'm just going to say, nah, that kind of looks thin. But anyway, so 5 millimeters apart and 6 instances, say OK. And what that does is it cuts through. Now it looks like that's not entirely right, so we can double click on the pattern down here and say instead of 5 millimeters, let's change this to, I don't know, 8 millimeters. And that is where parametrics are really, really awesome, right? Because you can make those changes and then pattern those. So hopefully that answers, Roman, your first question on how to do the cutouts. Now the second question, if we kind of zoom in here, is how to do these bumps that come out. So these aren't I guess you can call them cutouts or embossing if you want to go out, that sort of thing. So here would be a different way of doing this. And remember, there's always lots and lots of ways of doing this. But here's a kind of a good way. I'm going to create an offset plane right here from the top and maybe have this come down -75. So now I have a plane here. And I'm going to create another one that is at -70. That looks pretty good. So now you can see I have two planes right in here. I'm going to say modify and split face. So I want to split this body with one splitting tool here, and I'm going to do it again. Split this face with this tool, like that. So if I hide those planes, you can now see that this cylinder has been it hasn't been split into multiple bodies. I still have one body here, but the faces have been split. So I just have essentially an edge right here that I can do things with. Now this edge, I can right click on this and say press pull and say, I don't know, 5 millimeters. Way too big, probably 3 millimeters, something like that. And I have made something that pops out. Now those are kind of nice. If you look at this, there is kind of a little U-shaped sort of guy right there. And what that is a little bit easier transition. So I'm going to go to fillet and click on all four of these and try to put in a fillet. 1 millimeter. Looks pretty good. Looks pretty good. And again, we're going to go to create a pattern, rectangular pattern. So let's try to do features. This is not going to work, and I'm going to show you why. If we say that we want to pattern the offset faces, we can do that, and then pattern the fillet, we can do that. And we can select the direction, like that. And it kind of works, but now you kind of see that it's not patterning the actual face like that. And change this to 1 and try to click OK, and Fusion will not do it. And eventually it'll give an error down here. More info, it just says compute failed. No fillet edge found. So let's try to do this again with features of just the offset faces, like that, in this direction. And now you see that it still doesn't like to do it. Because this was based off of a split body, that is what it's having problems with. But no fear, there are other ways of doing this. You say pattern, rectangular pattern, and this time you can just go to faces. We just want to get these faces. So there's a fillet, flat, fillet, flat, fillet, flat, fillet. There we go. We do that in this direction. Now that looks good. Let's make this quantity of 1 and quantity of 6. You know, I'm just kind of very vaguely eyeballing this and say OK. And now we have these cool kind of ridges that come out there. And this is all parametric, right? So if I go back and I change this fillet from 1 millimeter to 0.5 millimeters, everything updates. So it makes it very easy to change those things. Now you can get even more fancy with this if you want to, play with the spacing and all of that by going in and saying modify change parameters. You can actually add in some user parameters here of the different spacing, the number of these kind of ridges that you want, so that you can enter those directly into the parametrics. I can kind of show you this. So let me say modify, change parameters, bump number, and we'll say 6, just like this. And we can go in and change this pattern to, instead of quantity 6, I can type BU, and it'll read in bump number right here, like that, and say OK. Now we still have 6, but you can have all of these things interrelate to each other. So we go to modify change parameters. If I change this expression to 7, and we go modify to compute all. It should change, or maybe I didn't do that properly. Oh, because I didn't save that. So bump number, you actually have to. Oh, well, that was one of the issues. So bump number, yeah. Here is one of the issues with that. So I created a millimeter unit, but it's not actually a millimeter unit. This isn't. It's we can say no units, angle, currency, like that. You could just say no units, and then you can just use this as the number of bumps. It's set to 7 millimeters, and number of bumps equals 7 millimeters doesn't mean anything. So, but the really nice thing about all of these parameters is that they can refer to each other. You can create a parameter that says bump distance is equal to bump number minus 2 or minus 3, right? And then that is a value of 4 millimeters. And so you can create all of these things that reference other things. So now you see that the distance is 3 millimeters less than whatever the bump number is. And that's how you can create very powerful things that you don't have to go back through your timeline. You can just change it all from this panel inside of here. That's pretty cool. Hopefully that answers those two questions. Let me go back like this and see if anybody has any questions. We don't have any questions yet, but that's kind of a demo on how to do that. And again, there's lots of different ways inside of tools to do things. And this is just kind of one easy way. Certainly as you start to use Fusion more, using those parameters is really, really powerful. Those parameters are actually everywhere inside of Fusion, even for things that you create in your sketches. And you can kind of uncover those by highlighting them over your mouse. But we don't have any questions yet, so I'm going to get to the second question that Roman asked, which is over here. So let me click on this and this. And let me start a new design here. And I'll just put this in a canvas as well. So the second question that he asked was how to create this kind of repeating pattern down here like you would see on these golf divot tools. These kind of slots that he's seen tutorials on how to cut it all the way out, but not how to do these. And I actually worked for quite some time. Let me go back to me here. I actually worked for quite some time today, and I'm sure that there's a way of doing this in a more parametric way, but I wasn't able to figure out how to do this in a way that auto updates. So let me show you how I would do this. And there might be ways of doing this with different formulae or other things, but I wasn't able to figure out how to do it. But if we just create a cylinder here, like that. So I just created a base little cylinder, and I'm going to create a sketch on the top. I can actually, there's a really cool thing called a slot right here, and you can do a center point slot. This is the center right there, and this is how wide I want it to be, and then it opens up like that. So I can do that. I can create another center point slot like this, and if I wanted to be very official to this, I could now draw a line between these two, and then I will use the extend tool. So SEX for extend, and kind of extend that out. And I actually use the extend tool pretty often, and it's actually kind of funny because all day I'm typing SEX. It's just kind of a funny little thing that I noticed. But now that line is out there, you can go in and create another slot like this, a center point slot that kind of locks on to these two guys and goes to here and then goes up, right? And then all of these can be dimensioned, right? So you can say dimension, I hit the D key from here to here is looks like I did 9, great. And then dimension from here to here could be 9 as well if I want it to be equal, but now it changed the size of these. I might actually want that, that's totally fine, or I can say always, you know, dimension from here to here is, looks like it's 14.8, let's say 15. Dimension from here to here, oops. Dimension from here to here, let's see what this does when I say 15. Makes it a little bit more, but now it looked like it pushed this one off, right? So if I undo that, it pushed it off the center a little bit. But anyway, so you can kind of play around with this. And then, you know, we have those 3 here. If I, you know, you can do all sorts of things. If you wanted, I can go like that and then break and break and then trim if I wanted to. I could do something like that. And then sketch mirror. You try not to actually use sketch mirror all that much because the sketch performance is not the best inside of Fusion. And if you do a lot of mirroring, you can get some issues in performance. This is kind of okay, right? But this is still getting pretty big. What I would maybe want to do is, instead of doing this, go out and create a mirror in the model environment. So I'll show it this way. So we created those on here, and then we just select these profiles with the Shift key held down, extrude down a little bit, and we get those cuts like that. Now the other way of doing this, if I just undo all of that, I can delete this kind of center line and say stop. So we have these. I can extrude these down however far I want, and then say create a mirror. And again, I could do faces. Now this is going to be a little bit tricky because I didn't build this on the origin. I built it over here, so I don't actually have a mirror line to connect to. So what I would want to do is maybe go back into the sketch and we just draw a line out like that. So I can't really see it, or actually I probably had that before if I turn on this sketch right here. No, yeah, I already had it before. So what I can do is say create a mirror of, I can't really do features because features included this one. So what I could actually do is say faces, or probably if this were a more complex design, what I would do is I would do one extrude for the center like that I'm not going to mirror, and then one extrude for these two guys, because I can now mirror that feature. So create a mirror of this feature, and I select the extrude, and the mirror plane I cannot select because I didn't create a plane. You need a plane for mirror. So what we can do is we use this line, we say construct a, where is this? Plane at angle. And I'm going to select this line right here, and it allows me to select whatever angle I want. In this case, I do just want 0. And now I can mirror across this. It gives me a good kind of shortcut to a center line. So now I can say create a mirror of these features, which was just this extrude on this mirror plane. And we have that. So that's nice. Any change to the sketch will automatically, you know, be updated on the other side and all of that. I'll turn off the sketch, and that's what we have. Pretty cool. That kind of replicates what you have right there. Now, I'm sure that there are probably some ways of doing this in a more mathematical function, of saying, you know, how much this goes down with creating sketch circles and all of that, but it didn't occur to me. I am talented. Actually, let me go like this. I am talented in, you know, doing this and maybe teaching, but I am an English major at heart, so I'm not a mathematics person or anything like that. So there might be some way of doing that and creating cool formulas that could have that auto update, but I don't entirely know it. So there's that. Okay, so we don't have any questions. What I want to talk about very briefly is multi-material printing. Let me hoist this guy over here. Ugh. So this is a printer that I just got, and I'll break it. I get my webcam out here, up and over. Okay. So what this is this is a Prusa i3 Mark II, very, very well reviewed 3D printer on the market. It won Make Magazine's top 3D printer in the last 3D printer kind of review that they did, or the shootout. But this also has the multi-material upgrade. The normal Prusa printers have just a single nozzle and are a direct drive extruder, which means that the drive gear that pushes the filament down through the heater is right next to the heater. It's all right there. When you upgrade to the multi-material, like this, I'm not sure if it's reversed for you, but I see it reversed on my screen. But this says multi-material, and we have 4 different filament lines coming into this, pushed by 4 different extruders on top. And with these little Teflon tubes that go down into this. And if you notice, maybe down here, if I can get the webcam going the right way, just one nozzle. All 4 of these go into kind of the same place, and the G code actually advances one filament in, and then it knows to retract that out, put another one in, purge the filament on the build plate, and then go off and go printing. Just pretty darn cool. I don't know if this will extend back here. It will. Yeah, and then just underneath you have some holes on the bottom to feed the filament in, and the filament goes and does its thing. Put this back over here. Drop it. Awesome. Yeah, so I have been printing actually quite a bit with that. Unfortunately, my 4-year-old has kind of stolen all of my multi-material prints because he thinks they're so awesome. But I do have some kind of examples. Now, what you would do with 4 different materials is 4 different colors, certainly, or you can just use 2 materials if you want, which would mean a normal material and soluble support material. This is a really awesome thing that I have been playing with. I had a couple of models that I was printing for a client that just weren't coming out, and I had to be very conservative about where my support materials were. It was actually a tibia, a 3D scan of somebody's broken, I guess, leg bone. And, it kind of printed up, but there was breaks in the bone, and so there was all the support material that was needed, and it was a super pain to remove in any other way with normal material, because you have to kind of get in there and dig it out. With soluble support material, I printed it actually upside down, and I was just able to rip off the soluble support material, so a lot of it just very easily separated. And then the rest of it, I did just soak in water, and I kind of picked out, and it came out beautifully. And I want to kind of show you what you would need to do multi-material printing. It's actually not that hard, and so I want to show you. And don't have any other questions, so let me go click like this and back. I'm going to show you 2 different ways. One is in Fusion, very easily. Let me create a box here. And this is actually something that I just did for a client. And I created a box, and now I'm going to move the box, just one face of it, to kind of create a nameplate. And kind of a nameplate like that. I'm going to create a sketch on this flat surface, and then just do a sketch of some text. Hello. Make this a little bit bigger. 30, and hello. In Arial is fine. And in the past, you had to explode this like it's just a text object. If I double click on this, I can edit it to whatever I want. In the past, you had to right click and say explode, but then you're not able to edit it. But you don't need to do that anymore for a lot of uses. This is still kind of a text object right here, but what we can do is we can do a press pull. And what that does is it acts like an extrude going in. Now, what I want to do in kind of this instance for multi-material printing is I don't want to cut. What I want to do is create a new body. What this does, when I say select, is you might think, okay, great, you know, it just maybe made like a little line on there, but it didn't. If we go to inspect and interference, with all of these bodies, we see that there is a lot of interference. This hello is interfering. And what I did is I created this hello, but I still have just a solid body here. It's going into solidness, which is bad, right? There's an intersection. What I would want to do is go to create or modify and combine. And the target body is my block, and the tool bodies are everything else. 2, 3, 4, 5, 6. And right now it's set to join, so these things have disappeared. I don't want join, but what I want is cut, because I do want to cut these bodies out of the main block because I want them to print in a different material. But the trick is here, it says keep tools. So instead of deleting my cutting tools, I'm going to keep them. It looks the same, but if we look at an interference, and I say select all of these bodies and compute, no interference is detected. Awesome. If we do a section analysis, starting on this side, we see that there are new bodies cut out of this, but they just perfectly coincide. Great. Now what we do with this is we want to save all of these out, and also note that we have 1, 2, 3, 4, 5, 6 different things, but we're going to end up with a little bit more, and I'll kind of tell you what this is, because the inside of this E right here and the inside of the O belongs to this block, but it won't for forever. So what we would want to do to save all of these out, it's actually super handy. You right click on the top object in here in Fusion and you say save as STL. And you says format binary structure one file or one file per body, which is what you want. You say okay, save it to the desktop and just say hello block. All right. And then what that did, you may be able to see this on replay, but what that did, if we open up Mesh Mixer, is, let me select all of these over here, like this. Zoop. Bring them all into Mesh Mixer. Put my shader correct here. We have all of these guys. So we have the block, H or E, L, L, O, H. They are all separate STL files. If you kind of, yeah, so essentially they were all saved as separate STLs to my hard drive, all in the correct position, which is super awesome. That's kind of just in Mesh Mixer. Then, just as this is very specific to the Prusa machine, but this is Slicer. This is a 3D slicing software, but this is specific for the multi-material Prusa i3 machine. You can kind of see Slicer Prusa edition up here, and we see up here, if you can see it on replay, make sure that you can. No, you can't. There. You can see this on replay, or everywhere, that we have different materials here, PLA, 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 and there's different presets. And what you would do is you would go back here and see, okay, body 1 was the main one. What I'm going to do is I'm going to add body 1, like that. We get a little block that says hello. And now we right-click on this block and say settings, and we say load part, and we load in all of the other parts, and they kind of show up here once I zoom it in a little bit, and all of our parts are there. And we can say, you know, body 1 gets printed in extruder 1, body 2, extruder 2, extruder 2, and do all of the letters. But this isn't actually right? So because you see this E, this little part of the E right here. Oh, that actually does work. That actually does work. You can actually click on the letters and just say H is extruder 2, E is 2, L, I already did it. This one I did wrong, and 0 for 2, and we say OK. And we can click on these filaments and say, I want the base to be in, extruder 1 to be in white, and extruder 2 to be in kind of a baby blue. Let's try that. And we say slice, and we say preview. And we see what this looks like. The multi-material creates what's called a wipe block, and this is how it changes colors. It kind of wipes and purges one color to the other during this. And if we somewhere go back to me here, what the wipe block looks like is I did a little print that looks like this. You can kind of see it was just like a little test that I did, and the wipe block for this looks like this. It goes from blue to orange, and it just kind of goes up. It didn't need to switch to orange until right at the top where orange was used. So underneath, it just has a very light fill pattern to not waste material. And that is great, and that's how it did that print. I have another one here you can kind of see with some hairiness on the sides, because this is soluble support material. This is from that print that I did of the broken tibia, where this is white material. Let's see if I can get it to focus. Where this is white material, and then it goes down to soluble support material. So this is actually pretty loose. If I were to put this in water, all of the soluble support material would eventually just dissolve away, which is pretty darn cool. That is how you do multi-material printing. Essentially, you just need a 3D model to be next to a 3D model in 3D space absolutely perfectly, but without overlapping. Because if they overlap, you can certainly export a file that has that, but then it's up to your slicer to figure out how to fix that overlap. Sometimes the slicer will do it just great, and sometimes it won't. I really wouldn't trust slicers to do a lot of repair. You should just repair that inside of other tools, or just have good output to start off with. Now I will answer some questions that came in while I was talking about that. I want to make sure that I answer people's questions with this. Quick question pertaining to Fusion and Mesh Mixer. Is there a way to capture the angles when using the transformation tools so that it can match the same changes in angles later to other objects? In Mesh Mixer, no. Mesh Mixer is not parametric. It's just called a piece of paper and a pen and just writing down what angles you're doing. You can make some precise things inside of Mesh Mixer using pivots, and you can lock things to pivots and make changes with that, but you're not building a history tree out of that. It's all just kind of remembering things. You can make very specific angle changes inside of Mesh Mixer in the transform tools, in all sorts of things, but there's no history tree. You just have to kind of remember what you're doing. In Fusion, absolutely, right? You can create, down on the bottom you have your history tree, but if you want to make really specific changes for things that you may that may affect your whole model, you would go into the user parameters and you would just say like obtuse angle and just say 135 degrees. So that later you don't have to search along down your timeline for every time you typed in 135, which may be several times. You can just reference that one angle in one user parameter and change it there. So hopefully that answered that question. And Eric, I think you said you tried soft material. Was that TPU like NinjaFlex? Wonder how that works with the Bowden tube design. I have not. So what the Bowden tube is, for people that don't know, is this tube right here. This is called a Bowden tube, right? Because it's actually named after a gentleman with the last name of Bowden. Because the pusher is up here. If you have really stiff filament, like most filament is, that's fine, right? It gets pushed here and then down in there and extrudes out. But actually, let me stop. Most printers are what's called a direct drive extruder, which means that the pusher is right here, and it really only has to push the filament a little bit until it gets heated. With a Bowden setup, you're pushing all of this down, and so there's a little bit of space in here for the filament to go into. I think these are, I didn't tighten them entirely fully. Let me take this out, right? So there's a little, there we go, a little tiny bit of space, a little bit of leeway. But that leeway, if you have a flexible filament, even a little bit of leeway can allow the filament to kind of bend inside. And that gets compounded over a long distance so that the filament has a lot of bend in it before it gets to the heating element. I have not printed, no, I have. No, I have actually. I did do a test with that. I have printed with the flexible filament from Maker Geeks, which is about a Shore, they say a Shore 70, but I don't think it's a Shore 70. It's more like a Shore 90. Shore is amount of flex to things, and it printed just fine. With that said, this actually. I hate to walk away from my webinar, but let me go in the other room and get some filament and let me show you. Hold on. All right, I'm back. Yeah, so if you have the question of how well do flexible filaments work, this is PVA. So this is the soluble support material, and this is actually super bendy. It's not Ninja Flex bendy, which is like springy. I haven't tried that yet. The Prusa forums say that you can do that with multi-material, and the nice thing is that the post-processor allows you to change the speed at which each material prints, and so I think you do have to turn the speed down. You can't print that flexible material at the same speed. Although, with that said, this kind of does fall even on its own a little bit, and I did not slow down at all when printing with this. I slowed down the whole print to about 50 millimeters per second, but I didn't slow down any more for this. Don't know about Ninja Flex, but this is, I don't know what the Shore hardness is on this, but this is PVA, so this is essentially a type of white glue, and it worked just fine at 50 millimeters per second with these Bowden tubes. Don't know if that answers your question, but it is pretty good, and this certainly is softer than the Maker Geeks flexible material that I also successfully printed with, if that helps. Now there are techniques inside of Mesh Mixer to do multi-material things, and I'll just show that very quickly. It's a little bit complex to do, but if I just bring in the bunny right here, these shaders are not right, and I'll just fix it with the inspector right here. Okay. Now, printing with multi-materials for something that's organic shape is actually really easy inside of Mesh Mixer. I'm just going to make a selection down the bunny like this. I'm going to click B to optimize that boundary to make it nice and smooth like that. And then all of the multi-material things inside of Mesh Mixer all work off of face groups. I'm going to say modify and create face group. If you don't see face groups, it's maybe because I'm pressing the space bar right now. It's maybe because you have this turned on. You want to make sure that this right one is darkened, is highlighted, and that's kind of the Mesh Mixer mode. All right, we have this, and we go to Edit to Generate Complex. And what that does is I can click on the inside of this, or just click anywhere on this, or double click on it, and then I can double click on, or I can click on the edge, and I can say I want this to cut in 2 millimeters, and say accept. Doesn't look any different, but we now have a new object down here that says bunny complex. And if we say split complex, now we have another bunny that looks just the same. And for some reason my shaders keep switching. Okay, but here's the really cool thing. If I turn off this bunny like this, we have an interior part that is 2 millimeters thick. If I go to this bunny, like that, we have a bunny that has been cut 2 millimeters, and I can go and export this as an STL, and I go and export this as an STL, and I assign these to different extruders. In order to do that inside of Mesh Mixer, you need to go to File, to Preferences, and make sure under File right here that your export is selection only, not the whole scene. The whole scene will export everything, and you want to make sure it's selection only so that you export this guy when it's selected, and then you go here and export this as different STLs and load them up. And that's how you do multi-material printing kind of in Mesh Mixer. I mean, there's more to that, but hopefully that kind of shows how easy it is to create multi-material prints inside of Mesh Mixer using just selections. And you can get very, very accurate with selections using crease angles and all of that if you need to. If anybody has any other questions, I would invite you to ask them now. I will talk more kind of about this printer as I have more experience with it. They're backed up on orders at Prusa for this, but this machine right here, I have to kind of show it again, is one of the most used printers on 3D hubs for people that need to make money doing 3D printing. It's a very, very quality printer with really, really good software and the ability to do 4 materials. Shoot, I forget how much I paid for this. I built this as a kit, I think for $700. Yeah, I think it was about $700 as a kit, and then the multi-material upgrade was $200 or $300 on top of that. I think I got in early and I paid a little bit less, but I think it's about $300. But really, for about $1,000, you can get a printer that by itself is really, really used by people that need to rely on these to like make money with printing, and the ability to do 4 different materials or 4 different colors or 3 colors and support material. There's just really nothing like it anywhere in the world at this price. You have to go up to very, very tens of thousands of dollars to get something like this in the fancy machines, but then they have their own benefits when you get up there as well. Does anybody have any questions? I invite you to ask them now, and if not, then I will see you next month. This webinar platform is getting upgraded, and you should have kind of a better experience next month with the replays and everything like that. But it looks like no other questions, so I really, really appreciate the people. Oh, yeah, you're welcome, Bill. I really appreciate the people that join these. And again, if you have any questions throughout the month, a lot of times I maybe just kind of answer them, or I really want to make you successful. So if you have questions about how to do things, and they're kind of, easy things that I can kind of rattle off to you, I'd be more than happy to help you. And if you really need help, like dedicated help, I do consulting. It's just part of, Honeypoint 3D. And, I'll record videos for you or do webinars or, live interactions. I do that quite a bit for professional users who just need things answered, and then usually just put me on retainer for an hour or 2 to just use up my time. So I'm more than welcome to do that. And then, send me questions for next month as they come up, and I'll be happy to answer them. All right. Well, thank you, everybody, and I will see you next month. See ya. Thanks.